Hello and welcome to this online video lecture about periodic trends. One of the powerful things about the periodic table is that it has arranged the elements in such a manner that we can use it to predict what the properties of different elements are in relationship to other elements. So what we're going to do here is we're going to go through several properties, and we're going to talk about the patterns on the periodic table that you would find for each property. And we're also going to define each property for you so that you know what the heck we're talking about. On the right, you'll see this little area that I've kind of labeled already. It says as you move, and then there's a right arrow and a down arrow. So basically what this is saying is for each property, we're going to say what happens as you move from left to right across a period on the periodic table, and from top to bottom down a group on the periodic table. So just as a refresher, the periodic table is arranged with rows and columns, and the rows of periodic tables are called periods, and they're labeled on the left of the periodic table usually, periods 1 through 7. The columns of a periodic table are called groups or families, and they're labeled across the top, and they can be labeled in different ways. Sometimes there are weird little A's and B's involved in that, but for this periodic table it labels them 1 to 18. So that's what I mean when I say across, left to right across a period, and top to bottom down a group. So let's get started. We're going to start with atomic radius. An atomic radius is pretty much what you think it is. It's basically a way for chemists to measure the size of an atom. And the way that they do that is they will measure how far apart the nuclei of the atoms are when two atoms of an element are bonded together. So it's half the distance between the nuclei of two identical atoms that are bonded together. Of two atoms bonded. It's basically if you always just ever think of atomic radius as the size of an atom from its center to its outer edge, that's basically what they're measuring when they're measuring this. So what do we see on the periodic table as we go from left to right across a period? The atomic radius actually goes down. It decreases. So if you start on the left side of the periodic table, like let's say we start over here at lithium, as we move across the period to beryllium, and then boron, carbon, nitrogen, oxygen, fluorine, and then neon, as we move across that period, the atoms are actually getting smaller. The atomic radius is decreasing. And the reason why that happens like that is because the relative charge that's in the electron cloud in the nucleus is increasing. And so since there's more charge, there's more attraction, and that just kind of sucks the electron cloud in a little bit tighter, making the atom smaller. That's kind of counterintuitive to some students. They more electrons, more protons and neutrons, they expect that the atoms would be getting bigger, but they don't. They actually get smaller across a period. Okay, so what happens when you go down a group? When you go down a group, the atomic radius does increase. And the reason why that happens is because every time you go down a group, you're adding an energy level to the atom's electron cloud. And so the extra energy level causes the electron cloud to get larger. So as you go down a group, whether it's from hydrogen to francium or nitrogen to bismuth, as you go down a group, the atom's atomic radius gets larger. So atomic radius across, left to right across a period, decreases, the atoms get smaller. And atomic radius, as you go from top to bottom down a group, the atoms get larger. So that brings us to our next property, which is ionization energy. Ionization energy is the energy change that happens when an element, a neutral atom of an element, loses one electron. That's called ionization energy. It's the energy change when that occurs. So what do we see on the periodic table in terms of how the energy changes when a neutral atom loses an electron? Well, as we go from left to right across a period, we start over here on the left with the metals like sodium and magnesium, and sodium and magnesium both want to lose electrons, whereas way over here, aluminum, silicon, phosphorus, sulfur, chlorine, you get into elements that want to gain electrons. So since we're talking about losing an electron, the atoms on the left of the periodic table, like the metals over here, they want to lose electrons, so it requires less energy for them to lose an electron than these atoms over here that want to gain electrons. They want more electrons. So in order to rip an electron from them when they're neutral, it requires a lot more energy to do that. So the trend then, as you go from left to right across a period, is that ionization energy goes up. Goes up. Now, as you go down the periodic table, the atoms are getting larger, the electron shells are getting larger, which means that the electrons are further away from the nucleus, and there's more electrons between the outer electrons and the electrons in the nucleus. So what we see in ionization energy as you go from top to bottom down a group is it actually becomes a little bit easier to remove them. And so the ionization energy goes down as you go down a group, a family. So ionization energy, the energy change when you remove an electron, one electron from a neutral atom, when you go from left to right across the periodic table, it goes up. And when you go from top to bottom down a group of the periodic table, it goes down. Okay. So the next property, as you can see down there at the bottom of the screen, is electron affinity. And this electron affinity is the energy change that happens when a neutral atom gains an electron. So let me just grab my pen here. So this is the energy change that happens when a neutral atom gains one electron. Now, we're going to put a little star by this one, a little exclamation point. Not because it's super duper any more important than the rest of these, but because electron affinity, those numbers are negative for almost every single element. So you have to remember that, and that kind of changes what I mean. It kind of changes what we mean when we say up and down. So if you think about it, almost every atom on the periodic table, if you're adding an electron to it, is going to actually release energy. And so that's what we see with the negative numbers that are the electron affinities. So let's get into this now and think about the patterns that we're going to see when neutral atoms are gaining electrons. As you start on the left of the periodic table and you move across to the right, here, let me bring it up real quick. You're starting with atoms that want to lose electrons, and you're moving over into atoms that want to gain electrons. And so what you would expect to see is you'd expect the atoms that want to gain electrons to release a lot more energy than the atoms that actually want to gain more electrons. I'm sorry, that want to lose electrons. So as you go from the atoms that want to lose electrons on the left over to the atoms that want to gain electrons on the right, what you see is a greater energy change. The atoms that want to gain electrons on the right, they're actually going to release more energy when that happens. And the atoms that want to lose electrons over on the left, they don't release quite as much energy when you force that electron upon them, because they want to lose an electron they already have, and you're forcing them to take another. The energy change is still negative, however. And so what we see is, as you go from left to right across the periodic table, the electron affinity goes down. Now remember, these are negative numbers. The electron affinity goes down because the atoms on the right release way more energy and become much more stable when they get that other atom that they want. And so what happens when you go from the top to the bottom of a group? Well, this trend isn't the best. This isn't a very strong trend, and there's a lot of exceptions to this general rule. But the general rule is, as you go from the top of a group down to the bottom of a group, the electron affinity actually goes up. And you have to remember what that means is that the atoms at the bottom of a group release less energy than the atoms at the top of a group when they gain an electron, because electron affinities are negative. So basically what that means is the atoms at the top of a group will accept that extra electron a little bit easier than the atoms at the bottom of a group in general. This trend is not the strongest of trends, but you can still use it to make predictions, and you'll be right more often than not if you follow this pattern. So that's electron affinity, and our next property is called electronegativity. Now this is I'm going to star this one. I'm going to star this one not because it's kind of a weird exception, because this one is actually quite important, and it's used in chemistry quite a bit, especially with bonding and things like that. So here we go. Electronegativity, it's an atom's ability to attract an electron when it's bonded to another atom and sharing that electron. So ability to attract a shared electron. So if an atom is bonded to another atom and they have different electronegativities, one of the atoms will be able to attract their shared electron more than the other atom will. And that's what electronegativity is a measure of. And this is a pretty darn important one. This one will be coming back in the course on advanced quizzes for sure later on. So what trends do we see? Well, as you go from the top of a group down to the bottom of a group, in general, the electronegativity decreases. Oops, I put that in the wrong spot. I started in the wrong order, but that's okay. So lithium's electronegativity is higher than francium's, and nitrogen's electronegativity is greater than bismuth's. As you go from the top of a group to the bottom, the electronegativity decreases. As you go from left on the periodic table to the right, the electronegativity increases. The highest electronegativity element on the periodic table is fluorine. It's got an electronegativity of 4. And if fluorine is bonded with another element, it's pretty much going to get that electron more than the other element is. And the lowest electronegativity element on the periodic table is francium. And it pretty much won't attract the electron at all. As a matter of fact, it'll probably just let the other element have it. Its electronegativity is so low. So that's electronegativity, and we've got two more. Hopefully I can get through them here. Metallic character is just kind of a measure of the general metal-like properties that the element has, and it's basically based on how easy it is for the metal to give away an electron. So we're just going to say, for this class, we're just going to say how metallic, oops, one T, two L's, how metallic an element is. If you're interested in metallic character and what it is precisely, you can do some research online. But for metallic character, what we see is, the groups 1 and 2, those are the alkali and alkaline earth metals, and as you go across to the right, you start to encounter the non-metals. So as you go from left to right across a period, the metallic character goes down. And then as you go from the top of a group down to the bottom of a group, like some of the groups, you go from non-metals into metals. Like for example, at the top of group 14 is carbon, which is a non-metal. And as you move down that group, you eventually get to lead, which is a metal. So as you go from top to bottom, the metallic character increases. And the last one is valence electrons. Valence electrons, pretty simple. The number of valence electrons is really, really, really easy. As you go from left to right, it increases. It actually increases by 1 every time you move over a group left to right. And as you go from top to bottom, it stays the same, because all of the elements within a group have the same number of valence electrons. So there you go. Those are your periodic trends. Make sure you know those, and you'll be all set for your advanced quiz. Thanks for watching, and as always, if you have any questions, feel free to